All right, so we are going to continue examples 1 and example number 2 from the 3.6 notes, the mathematical models. Um, we are going to start with example number 1, part E. Now, my notes here do look a little different. These are the ones that I had prepared from what we had earlier. However, you can see that our final equation or our final function did turn out to be the same. Okay, so what I'm going to ask you to do is go ahead and get your graphing calculator out. And we are going to, let me see while you guys are doing that. Let's see. Nope, that didn't do it. All right, there we go. That's what I'm looking for. Okay, so we're going to use a graphing calculator to graph the function where x is greater than or equal to 0, and then we're going to round to 2 decimal places where the local minimum is. Okay, so this is just kind of showing you guys how to use your graphing calculator to work these things through. So let's go ahead and start off with graphing this equation here. So the way we do that, again, is go to y equals second x squared. We're going to go ahead and type this function in. Okay, so your graph should look something like this. Okay, and then let's go ahead and adjust the window. We don't care about anything less than 0, so I'm going to go ahead and adjust my window so that all of my x values, remember that's your x min and x max, my minimum x value should be 0. And we'll go ahead and change, I think we can leave it here. We'll leave it at 10 for right now, and we'll see where we're at. Okay. All right, so let's go ahead and graph. Okay, so we have a function that kind of looks like this. All right. And we're looking for the local minimum. Let's check and make sure. So notice that it's kind of going down and then back up. Let's make sure that there's no higher value that we're dealing with that may, let's change that to 20, okay, graph, yeah, so it's just kind of going straight up. All right, so I'm going to change my window back to y max is 10. All right, so notice that right down here we have a minimum value or a local minimum value. Remember, local minimum isn't the smallest it goes, it's just in the region that we're looking for. It's just the smallest it is in that region. So in this case, x is greater than 0, so the smallest it gets is somewhere right in here. Okay, so the way we're going to do that is we're going to go to second, trace, and we want to find the minimum value. Okay, and it's going to ask you for your left bound. So you need to find your cursor. Right now it's at x equals 5, so I need to scroll to the left until I can start seeing my cursor. All right, so we have our cursor. I'm going to scroll to the left of where I think the minimum is. I'm going to hit enter. Then it's going to ask me for the right bound, so I'm going to scroll to the right where I think it is, which is right about there. And then it's going to ask you to guess. You don't have to guess. You can get really close if you want to, but it's going to do it regardless of what you do. I'm going to hit enter. So we have our local minimum. Okay, so it says round to 2 decimal places for the local minimum. So your local minimum is at x equals 0.71, and the y value there would be y equals 0.87. Okay? All right, so that's how you're going to use your calculator for that one. Now, again, I'm going to show you guys really quickly just how to evaluate these on your calculator. So once you have your function in the graph, you can go to, what was it? It's alpha trace y1, which is the one that we should have put it in, and you're simply going to put in the value inside of parentheses, and it'll calculate it for you. And notice this is what we, let's see, I didn't check it here, but this is what we got in our original notes. Okay, and you can do that really quickly with these. Now, the problem coming when you get to part D, if you do part D, it will most likely give you decimals. I don't know if my mouse will work with me. Hold on. All right, so y1, let's do alpha, we're going to do a fraction, square root of 2 over 2, parentheses, and yeah, so it's going to give you a decimal here. You're not going to be able to convert it back to fractions, so I would definitely suggest knowing how to work these out. I do expect your answer to not be at a decimal. All right. Now, let's go ahead and take a look at part C and D of example number 2 here. All right, so we're going to do the same thing. So we came up with this function. Okay, so remember a of x is equal to, we just had 25x minus x cubed. I rearranged it here. Not a big deal. Our domain should have been from 0 to 5 because those are the only x values that we can actually pick from here. Okay. So now, let's go ahead and do part C. So part C says we want to graph a of x. So I'm going to go ahead and clear this graph out. Okay. And I'm going to type our function in. I'll type it in how we had it earlier. So this would be 25x minus x to the third power. And we're going to take a look at what this looks like. Oh, we do need to change our window though. So a way to get your window back to normal. So notice that here, I guess we do have a domain. So we can go ahead and change our domain to the one that we need. So we need it from 0 to 5, right? So 0 to 5, our y values will be the same. Okay, so we're going to hit graph. And there we have it. Notice that there's a big portion of this that's missing off of the graph. So let's go ahead and adjust our window to make it fit. It doesn't look like we're really worried about anything below the x-axis because we're looking at the largest value. Okay, so I'm going to go ahead and change my y minimum to 0, and let's change my maximum value to, let's make it 20 and see what happens. Okay, still missing it, so I'm going to adjust it again. We'll do maybe 40 this time. All right, we're getting closer. All right, so let's do maybe 60. All right, so now it's fitting. Okay, so notice that this represents the area. So the bottom row represents your x. Okay, so x is equal to 0, x is equal to 5, x equals 2, 3, 4, and 5. As your x's get bigger, your area actually increases. Okay. However, so this represents your area. So as your x gets bigger, your area is increasing. Okay. Now there is a point where your x's are so big that your area starts decreasing. Okay. So I challenge you guys to go ahead and test this to kind of see what happens. Notice that the peak is right here, right around, let's see, 1, 2, 3. So right here around x equals 3. See what happens between x equals 2 and x equals 4 and see if that holds true. Okay, but let's go ahead and take a look at part D. So it says, for what value is x the largest? By the way, graphing on the graphing calculator is more than enough. I'm really just mostly looking for the part being able to calculate for part D. Okay. All right, so for what value of x is the area the largest? So, wrong thing, sorry, graph. So we're going to go to second calculate, or second trace. For the largest, we're looking for maximum, right? Okay, so it's going to ask us for the left bound. So I'm going to hit to the left of the peak, to the right of the peak, and then we're going to hit enter. All right, so the x value, okay, so remember that we said the x with the width, so the largest width that we can have to maximize, or the width that maximizes the area is about, we'll go ahead and say about 2.89. Okay, so we'll round to 2 decimal places here. So x is about 2.89. And the maximized area is 48.1 or 48.11. Okay, so a way of interpreting this, you could say that a width of 2.89, whatever the units are, will maximize the area, and the maximum area being 48.11 units, or whatever we're talking about. All right, so that's all I'm going to do for the calculator. If you have questions on using the calculator, please let me know. I will be posting some other notes here in just a little bit to kind of go along with these. Okay, and I'll be working through some of the homework problems.